The Great Escape. Have you seen that one? It's
No.
Steve McQueen. It's old. Charles Bronson, Steve McQueen. And it's an escape from a World War II prison camp.
Oh. Okay, so there's
They're
a
pilots.
Okay.
It's a true story.
But this is a parody of
Yeah.
that. Okay.
Yeah, and it was British. It was a British camp in World War II.
Oh, I've seen that one. Yes.
Yeah.
Yep.
It was.
Yeah, that was an interesting one because they did not quite depict the Nazis to be as nasty as people think they are. But there are still, some less nasty people in that camp.
Yeah.
Yep.
Yeah, because it wasn't a concentration camp. It was just a sort of a work camp for down pilots specifically.
Yep.
That camp.
Okay, so let's go ahead and get today's class started. We got some really kind of interesting stuff. I spent some time to take a look at several items that were on my backlog. Or it's called a what? Is it a backlog?
Backlog.
Yeah. Okay.
And this would be like a sprint. So you took something off of the backlog
Yep.
to.
As soon as I can log in.
Middle's like, no, you're trying to get rid of me.
Yeah, it has to do with it's muscle memory. I cannot really say what the password is, but I know how to type it.
Yeah. Yeah.
Or then it's time to change it.
No. Because now, no matter how much you torture him, he cannot give out the password. He doesn't know it. It's the perfect password.
I know some people who play the piano, they would actually use the sequence of a particular, section of a piano piece, and then use that to inspire the password. So the password makes absolutely no sense when you look at the characters, but when you look at the fingering and the sequencing, actually plays a particular tune.
Mm-hmm.
So that's one way to do it. I'm pretty sure if you play the guitar or violin, you can do something like that. But then with the violin, you can only use one hand, so your password has to be typable with only your left hand.
And you have to hold the keyboard.
Yeah. But if you play the flute, you can do it with both hands.
I got my password. Let me.
Okay, so we got some interesting stuff. Okay, Alpha is not here. Otherwise, I got some disappointment for her because the state fair thing may not be happening, and I think she's working on the Dieselzilla app. So that she may not be very happy to hear that. Okay, so I added one section called Advanced Topics to basically include everything that does not fall into the other categories. So as I put into these items, I realized that Firebase is probably the first thing that I want to talk about in terms of authentication. But before we do that, I'm going to go to Android use of key pairs and certificates, because if you want to push or publish your app, you'll have to deal with that first. So we'll go ahead and start with this one, and I'm going to start the Android Studio. There's a big update coming up. So
is there a way to update Android Studio without opening up the Studio proper?
Probably so. Uh-oh. Did I do something stupid?
You're pointing to the SDK, not...
Oh, okay. Actually, that was it.
It auto-completed to the wrong...
Yeah, I'm pretty sure there's a way to do the update, because I think there's a script to update the SDK as opposed to the Studio itself. So
yeah, there is a way to do it for the SDK. That's what I use for my GitLab instance.
That's one thing that you might want to do, one of these days, depending on whether the class wants to learn that or not. That's something that, if you agree to it,
I'm willing to
we can share, that information too. So basically, what Darren has figured out is how to use a GitLab, which is kind of like a freer version of GitHub. And he figured out, how to build apps on the other side, on the server side, by just pushing the source code to the repository. So you don't have to fire up, Android Studio to rebuild the APK.
No.
So I thought that was kind of interesting. And the approach is universal, right? The approach is universal as long as you can specify the virtual server that is used to build applications. Can be Java, can be C++, can be whatever you want to do. If you know how to do it on a regular server, you can send, I guess, in this case, you'll send a virtual machine over to the GitLab side.
Yeah.
And when you push the source code, when you update the source code in the repository, then you can activate the virtual server, rebuild the whole thing, and can it push the finished product to somewhere else too?
Yeah, it keeps a copy. You just go into the build and click download.
Mm-hmm.
So this is all that DevOps stuff, right?
Yeah.
The whole thing of DevOps now is pick up a package of software and deploy it on a container.
Yeah, GitLab is awesome. I mean, there's so much you can do with their setup over and beyond what GitHub does and offers. And it's all free. They don't.
Yeah. So one of these days, if you want to, you can just kind of show us, how it's done. Just the main, steps of doing it.
Yeah.
So that would be kind of cool because all of these are really kind of up to date, tools that were not available in the past because resources was not available to do it. Because you have to basically fire up a virtual server to do all the build and then take it down, and that technology was not mature enough. Even 5 years ago, the technology was not mature enough. So cool stuff. So what we'll do today is to first talk about key pair concepts. Because you will need that in order to publish your app through Google Play. Okay, so that's the first thing we'll do. And since I got this already updated, okay, it's doing the last build. Whenever you want to publish your app, you have to sign it. So you have to go to build and select generate signed APK. Now this can be done pretty easily. Okay. For those of you who have been managing websites and you have your SSL certificate and stuff like that, you probably would think, oh, this is going to be a long process because we have to contact Google and Google has to verify your actual presence, your who you claim you are. You have to supply the email address. They're gonna send you an email and wait for your reply. Blah 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 blah. No, it is a whole lot easier. Okay, so I'm doing it from scratch right now. So the first thing you need to do is to create a key store, which is a single file that can store multiple keys. So you just say create new if you don't have one already, and you can specify the path, anywhere you want to, and give it a file name. Okay, so you can put it into the root of your user account if you want to. So I'm going to put it over here, and I'll just call that, Android keys. Okay, you can name it any way you want. It will automatically have an extension of JKS, which I'm guessing is Java Key Store. Okay, click that. You can give it a password. Okay, so I'm going to use a really stupid password here. And no, it is not stupid. STUPID. I guess it can be stupid, but it's not.
But it is.
No, it's 5 instead of ST. 5, 7. UP and then 1D, right? Okay, and then the key itself, also can have a password. So I'm gonna use test0 as my test key. So it's gonna have the same stupid password. And Android actually recommends. Okay, this is too long. There we go. So Android actually recommends that you use validity to be at least 25 years. The reason is if you change your key that you use to sign your app and somebody else is installing your app and want to continuously get updates from your Google Play Store, whenever you change your key, it won't update anymore. It'll be considered a new app. Okay, so we'll go back and talk about what the key actually does in reality. So the rest of this is basically your certificate. So you basically indicate your first and last name. Okay, fine. Organizational unit, we'll just use ARC over here. Okay, and organization is gonna be the same. We're in Sacramento, California, the United States. Okay, so we fill in all this information. So one question you might want to ask is, what is preventing me from, using somebody else's name and call myself the Wells Fargo Bank or Bank of America? There's absolutely nothing that can stop me from claiming to be some other organization and to be somebody else. Okay? All right. So in this whole process, you just click OK. Okay, that creates the key store, and we have one new key created in the process as well. We click next, and now we can say, okay, what do you want to do with this key here? And you will have to click at least one of these two. You have to specify that you're using this key to sign the jar file, or do you want to sign the entire APK? And I think you can click both of them, okay, just like that. And then when you click finish, it's going to apply the signature, and it will generate an actual APK file with that signature, or with a signature in it, and also your certificate. That's going to be in this particular folder. Okay, so we'll click finish, and it's going to do some work. Okay. And now we have an APK file that is signed. And any APK file that is signed and you have a Google Play account, you can start to publish. Now, Google Play does require you to prepare some promotional material, like a video, screenshots at different resolutions, your icon and stuff like that, which I don't have ready in this case. But once you have all of those things ready and a signed APK file, you can start to publish your app. Okay. So before let's go back to these notes here. So I will describe what is key pair encryption, because that's actually the idea behind a certificate. So we'll start with some general description of key pair concept, which is actually going to be useful regardless of whether you're developing Android apps or just want to understand a little bit more about certificates in general for websites. Okay, so key pair encryption is based on a key pair mechanism to generate two different keys. So the key generation process will generate two keys, and these two keys are different. So for our discussion purposes, I'm just going to call these K1 and K2. Any content that is encrypted by K1, the first key, can only be deciphered using K2, the second key, and vice versa. Content encrypted using K2 can only be deciphered using K1. Is that okay? So it's a very interesting concept, because when we think about encryption and keys and stuff like that, in real life especially, we have one single key that is used to lock and unlock. Okay, here's my key fob, for my car. Okay, it's the very same key. When I lock my car, I use this key. When I unlock the car, I use the same key. So it's not a pair of keys. Key pair encryption is basically saying, every time you generate keys, you have two keys. If I lock the car using this key, I can only use the other key to unlock the car. If I lock the car using the other key, I can only use the first key to unlock the car. Is that okay? So that's kind of interesting, because now I can leave one key in my office, my public key. If I use my private key to lock the car, I can always use my public key to unlock the car, which is not safe. But if I use the public key, I can tell someone, oh, can you go to my office, use my public key and lock my car? That's okay. But everybody has access to my public key, and that's why there's a name of public key. But they can only use it to lock my car. I walk up to my car and go like, okay, it's locked by the, locked by the public key. And since I'm the only person with the private key, and therefore the name private key, so I'm the only person who can unlock it, but everybody can help me lock my car. Is that okay? So that's the entire thing about key pair encryption, is one key can be designated as the public key, and the other key can be designated as the private key. Yep.
So if information is going this way, it's locked with the public key, unlocked with the private. But when it goes back this way, it's a different set of keys, right?
That is correct, because in addition to having a public versus a private key, now you have to think about, okay, whose key pair am I using? Am I using the sender's key pair, or am I using the recipient's key pair? Okay, In some situations, it's described here as well, but in some situations you want to use the recipient's key pair or the public key of the recipient, and other times you want to use the private key of the sender to do the encryption, depending on the intention of the mechanism. Okay, so we're now moving forward to this part here. So key pair addresses two major concerns in computer security. The first concern is encryption, content encryption. So with content encryption, the whole purpose is I only want the intended recipient to be able to read the content of whatever I'm sending. Okay, so I can give you a good example here. Okay, so we'll go to Gmail is a good one. Okay, so we go to gmail.com, and the way you can tell that this is actually going through encryption is because of this little symbol here. Okay, it is encrypted. In other words, people can be sniffing this traffic. They can use they can tap off the router, tap off a hub. They can just tap the line itself and just sniff all the packets. But everything is SSL encrypted in this case, so they can sniff the encrypted traffic. But to a person without the private key or without the necessary key to decipher the content, it's just gibberish. Okay, and since this computer has the necessary key to decipher the content, so I'm the only person who can actually read the messages. Is that making any sense? Any content on this web page, anything that is going through HTTPS, is end-to-end encrypted. Questions, concerns?
That's from the web server to you.
Yes. It looks like some people have some questions.
And that's using your public key.
Well, I know we use the public key to contact Google, and they use the private key to decode the fact that we requested a web page. How did they switch the security so that they can encrypt something that only we decode?
They actually generate a new key pair for a particular session.
But don't they have to send that over the wire?
They have to. So when you contact them, you have the original request is already encrypted. So you're using their public key to encrypt your request, to send it back to Google. So no one else on the internet can actually read the actual request itself.
Agreed.
So the entire the URL like this one, the post content and all of that stuff is actually encrypted.
And it needs a private key to decrypt it.
And Google has the private key to decipher it. So Google read the URL, and go like, okay, I see that you want to access this particular message. Okay, so in that transaction, when Google replies, it is going to reply with not only, let's see, I know it generates a temporary key pair for a particular connection. So that way, the reverse way is also encrypted correctly.
Yeah, that's the process I don't fully understand.
Yeah, there's a handshake process,
Yeah, it's not true end-to-end encryption. It's partial encryption. So it is secure going both ways, but it doesn't have like private key going on both ends.
So the return way is a single key, right? It's not
Yeah.
it's a single key, not a key pair.
Yeah.
Yeah, but it does transmit back a key, so that the content will still be encrypted.
I believe it is.
Mm-hmm.
I just don't know how they do it. I get lost in that last,
The
I never go to
handshake.
the certificate authority to verify this. The digital certificate that you gave me is really the
Mhm.
one I think you should use. Right?
Right.
That's my implicit trust.
Right.
Right. And then I start using that as your public key, and then I trust that you talk back to me. But I get lost how yours becomes secure again.
Because in order to secure the content, you have to use the recipient's key or use a key that is shared by both the transmitter and the receiver.
I guess I could send him my key when I first make the connection.
Send your public key.
Yeah, I could dynamically generate a key, send it to you under your private key that you can
Mhm.
decrypt, and then you know what it is. So it's probably something as simple as that.
Well, we can find out. SSL Well, let's see if we can find a sequence diagram, because then I can show you what a sequence diagram looks like, and on top of that we can understand SSL. So there we go, sequence diagram. There we go. Okay, so that looks like that might be useful. Okay, this is good. Okay, because it's helping us to illustrate two things at once. The first one is what a sequence diagram is, which is a part of the UML specification, Unified Modeling Language. So a sequence diagram is basically a timeline, okay? But the timeline, which is, so time goes from top to bottom, okay? That's, the vertical axis is time. But it also shows you interaction between the parties, okay? So the horizontal lines going across is indicating the interaction between the two things. And each vertical line is called a lane, L-A-N-E, lane. And then the horizontal lines are basically messages that are being passed between the various parties, represented by the lanes. So in this case, the SSL client, send a hello, which includes cryptographic information, and then the server replies with the server certificate, and then the client, has a key exchange. So this is the step where, the client, can send over its own public key, so that the server can use that public key to finish. Basically, now the server and the client have both keys, have the necessary part of both key pairs in order to do encryption in both directions. So that's the handshake, that makes it happen.
Right there at 4, it does a dynamic key.
Right. So it's a dynamic key, which means it is basically generated on the fly.
The only one that knows it now is the server.
Right.
Yeah.
And it's not used again in another session.
Perfect.
Yep.
And certificate is held by a third party, right?
It's issued by a third party. So in order for a full certificate to happen, what you do is you have to make a certificate request, and it has to be encrypted, with your own private key. And then you send that to a certificate authority. And then the certificate authority will have some way to authenticate and say that yes, you are who you claim to be. And usually it has to do with your domain name. So with a web certificate, typically, you would have the domain name as a part of the certificate itself. I am, drtech.org or something like that. Okay, so they would use, they will require you to have an email address corresponding to your domain name in order to authenticate that you are who you claim to be. So it's an automated process. Nobody's going to call you, to basically say, okay, are you, this person and whatnot. And then once they can validate that you are who you claim to be, according to their standard, then they can sign the certificate.
Yeah. But they're using your private key and your information together to say, yes, this is who I am.
And then a lot of them, for like a tier 2 certificate, which is what my domain has, is they use also credit card information. So my company that I went through is Komodo. They took the credit card, and so they actually get the billing information of the person who supposedly owns the domain, along with just having that email address too. And that is how they also generate certificate.
So this is what a certificate looks like, from the side of the client. Okay, so this is what a server certificate looks like from the client perspective. So it has, all of these different fields. When you look at the certificate itself, it has a version number. You can configure a client to ignore anything that is less than a particular version, because when they find a flaw, with the mechanism, they might, obsolete or deprecate, earlier versions of, certificates. So your browser actually, probably is already configured to ignore or to reject certificates lower than a particular version. It will tell you the serial number, signature algorithm, which is a well-known algorithm usually, and this is the issuer. Now in this case, it doesn't really show you the details because the issuer is exactly the same as the company that it is authenticating. Okay, so that doesn't help to illustrate that. Let me pick another example. So we'll go to Wells Fargo, okay,
Yeah.
wellsfargo.com or BFA, any one of those. And you can look through exactly the same thing. This is Firefox. So you click the little lock sign, and then you go to more information, go to security, view certificate, and it will display kind of the same information. But in this case, when you look at the certificate, the issuer is not Wells Fargo. The issuer, which is your certificate authority, is Symantec. Okay, so Symantec is one of the companies who are known as certificate authorities, or they are basically known to hold a root certificate. Okay. All right. So after this, you can look at the validity. It basically says, it specifies the time frame of the validity of this particular certificate, and then you look at the subject. Now the subject is telling you, okay, who is the owner of this certificate? Not the issuer. This is the owner of the certificate. So in this case, it is using CN or common name to identify the website, okay, the actual domain name where this certificate belongs to. So what needs to happen before this certificate is signed by Symantec is Symantec will probably need to find a way to make sure that whoever is generating the certificate request, okay, is in fact associated with wellsfargo.com, the domain name. Now that can be done in various ways. Okay, it can be done by NSLOOKUP, email, and so on and so forth. Okay, whoever owns the DNS entry of wellsfargo.com, probably is the actual owner of that particular domain. And as a result, if you can validate that, make that connection, then you can say, okay, whoever is making the request for the certificate is the proper owner. And then what Symantec would do is to sign the certificate itself. Okay, we'll talk about what is signing a certificate a little bit later. And you can also see that it includes information like the location, San Francisco. This is the organization, which is the full name of the organization. You can use anything you want over there. And then OU, I'm not really quite sure what organization unit is compared to organization. Does anyone know the main difference between those two? Okay. Country, easy, state, location, organization. OU is organization unit, which is probably a larger group that Wells Fargo belongs to. I'm not really 100% sure. And then CN is common name. In the case of a website or web certificate, it is the domain name. You can also look at Moodle. So when you go to the Moodle website, which I already have one of the tabs open, you can go here and do exactly the same thing. Go to certificate and say view certificate, and then go to details. And you can see that the issuer is, in this case, InCommon, which is a company that the district has a contract with, but it's not the district itself. In fact, we know that the issuer is in Ann Arbor in Michigan. But when you look at the subject, then we have the common name, once again, is the domain name. And then LRCCD, in this case, is the OU. So I think the OU is a more abbreviated name of the organization, whereas the organization is the long, kind of verbose name of whatever the entity is. Location is Sacramento, state is California, and this one has an additional object identifier, which is the zip code, and also the country is US. Is that okay so far? Yep, go ahead.
But the purpose is that the end user knows that they're on a legitimate site, right?
Yes, but the certificate itself doesn't give you that, okay? So in this case, you can have what we call a self-signed certificate, okay? In other words, I'm the one making the request, and I'm the one signing the request too. We'll talk about the signing process a little bit later on, but you can self-sign a certificate. So how can the browser know that, hey, this is suspicious, somebody is self-signing?
Well, yeah, the certificate's legitimate. It's whether you trust the certificate or not. So
right.
Now we're going to go see which issuing authority we trust.
Yes. So in your browser, you actually have a way to find that out. So if you go to Advanced, you go to Certificates, Views, Certificates. So we have these certificates here. And this is under the tab of authorities, which means all of these companies are trusted by Mozilla.org. Okay, so Mozilla.org, is basically has done something to basically say, okay, these companies we know, okay, they can do it by physical mail, they can do it by actually going on site, making sure that those people are who they claim to be, and various things. But these things, these certificates, are already pre-installed with your browser. Okay, so anything that is signed by one of these certificates implicitly is trusted as well, because we trust these certificates, we trust the company that these certificates are representing. So if a new website comes in and it is signed, the certificate is signed by one of these what we call root certificates, then it is implicitly trusted as well by the browser.
So when you say signed, does that mean it's encoded with the certificate's public key? I mean, or
we'll talk about what signing is, because it also has to do with key pairs. But that's a good question. Yep.
So you say Google is a self-signer, so would it be in that list?
Google can be a self-signer because it is on this list. So if you go down to Google, I think it has to be there. GoDaddy is one. Oh, where's Google? There's no search capability, because Google may not be under actual Google.
Is it under Alphabet? I wonder if when they updated it.
That's possible, because I know they changed their name. We know Amazon is here.
Amazon.
And there's no search capability, which is kind of,
Stupid.
yeah. But most people wouldn't go here. Most people do not have to go here.
It's weird.
Yeah, I don't see Google being an authority, but it may be under a name that we don't
Right.
usually associate with Google. But so this is the idea. You have to have these installed. In the document that I that I wrote, okay, which is all these tabs. Okay, it's one of the earlier ones. Nope. Okay, there we go. I think it's this one. So with the document that I wrote, there's a link at the very bottom here. There we go. So this part, basically outlines what Mozilla is going to, what Mozilla has to do in order to include a certificate as a root certificate, which is what comes with the browser. So this is a long laundry list of stuff, and some of these are really kind of fuzzy. They don't tell you exactly what they will do to establish that. Like, we will determine which CA certificates are included by Mozilla based on the benefits and risk of such inclusion to typical users of those products. So if I want to include my own, certificate as a root certificate, then Mozilla is going to say, okay, so how many people, is this going to benefit? Well, all 30 of my students. Mozilla is going to go like, nah, we're not going to do that. Okay. Or if I'm in the state of California, on the other hand, they will say, oh, okay, you have at least millions of users, so maybe we'll consider adding your certificate as a root certificate. Okay, but some of these are really kind of fuzzy. We'll consider adding additional CA certificates to default certificate set upon request by an authorized representative of the subject CA. So the subject CA in this case is, I am moodle.lostreals.edu is the subject CA. Or Lost Reals is the representative of that. So they outline, all the requirements. Okay, so when all these requirements are met, then an organization can submit a certificate as a root certificate. Is that okay? So it's a pretty rigorous process. Okay, it's not just like everybody can just say, hey, I want you to include my certificate as a root certificate, then that will make me a certificate authority. It doesn't happen like that. Okay, so the contrast is getting back to the app here. Okay, so getting back to the app, we have just made a release APK which has its own certificate, okay? Which is required. If you want to publish your app through Google Play Store, you will need to have your application signed with a certificate included in the APK. So once again, going back to my own notes here. Yes, go ahead.
So when you did the what did you generate signed APK, it automatically built it, and
Yes.
that's a full built copy.
It's a full build that is ready to be released. That is ready to go through the Google Play Store mechanism so they can be distributed, downloaded by people, and get installed on whatever devices. So here's a command which works in Linux. I'm not sure in Windows what you have to install to make it work, but I can show you what it is going to show when you run it in Linux. So let me show you what that command is going to do. So we have to go back to the Android Studio projects. We go to, oh, that's not where I put it. Where did I put that? Oh, just camera app. Okay, there we go. So camera app 1.app. And the file is right here. This is the actual APK file. So now we can run the command. Unzip-p is basically unzipping a file, but also making the output, the standard output of the command becomes the actual output of the program itself. So in this case, it's app.release -release, and then meta-inf is the subfolder in the zip file. An APK file is basically a zip file with a different extension. If you want to unzip an APK file in Windows, you will first have to rename the file to have a ZIP extension, because Windows associates the extension to what it can do with the file. So with an APK, Windows says, I don't know what to do with it. Okay, well, it probably does. It just doesn't want to do it because it has to do with Android, a competing company. So it will say, nope, don't know what to do with this. But when you rename the file with an ZIP extension, then we go like, oh, I know how to do this. I know how to decompress this file. So if you want to do the same thing in Windows, you will have to rename the file first to have a ZIP extension. Then you can just double-click the file, and Windows knows how to decompress the file. Question?
I found out their certificate, their root certificate, is actually signed by GeoTrust Global.
Okay.
So that's why it wasn't showing up on the list.
Thank you.
Yeah.
So is GeoTrust Global a part of the Google group?
No, they're independent.
They're independent. Okay.
Yeah.
So did you find, is that the root certificate?
That's the actual root certificate.
Okay. But
And
when
then
we
Google-
looked at Google Gmail, it said it is self-signed.
It is because they GeoTrust signs Google's root certificate, and then Google can then act as a certificate authority to their own services.
But how come we cannot find Google in the root
Because
certificate
that one's
list?
not what's listed. It's GeoTrust
Okay.
is listed, and so that's it's gonna look and see that.
So they considered a non-root Google? They
Yeah,
get a
they're-
secondary
yeah.
trust?
Yeah, they're basically a step down from true root authority.
I see.
Okay, so I'm just running this command here. The biggest problem is how do you install OpenSSL in Windows if you want to do this in Windows. But these are all pretty standard packages in Debian Linux. Okay, so here's the entire command. So it gives you the algorithm. This is the actual signature of the certificate itself, and here's the public key of the certificate. So it is okay to include a public key in the certificate because that's just a public key, and you can also see how the issuer is identical to the subject. Do you see how these two lines are completely the same? They're exactly identical. So what that tells you is this is a self-signed certificate. Okay, it is not issued by a certificate authority. it is issued by exactly the same organization who is also the subject. Is that okay? And if you look at published apps online, you will find that most apps have exactly the same property. Okay? The issuer and the subject are exactly the same, which basically means there's no accountability when you look at a particular app. If I claim to be wellsfargo.com, nobody can say that I'm not. Yep.
The reason for that is the cost? Is that why? Is it cost?
I think it has to do with how difficult it will become when a developer wants to have a certificate included in the app.
I see.
So if you imagine that you have to go through the same rigorous process of getting a signed certificate for a domain name or for a website, Google has to go through a lot more trouble, and the developers also have to go through a lot more trouble to get their certificate working. And I think Android intentionally lowered the barrier so that more people can basically push apps through their Google Play engine.
It would be nice if when you pay for your account, because you got to give them money anyways, if they could just give you a certificate signed by them.
Correct. But people lose their certificates. And so because if you think about the webmasters of websites, as opposed to or at least websites that require an SSL certificate, so they tend to be like larger organizations and whatnot, as opposed to developers of Android applications, you will probably find that Android app developers span across a larger spectrum of people, as opposed to the webmasters corresponding to websites where an SSL certificate is actually required. Okay, does that make sense? And as a result, Android doesn't want to deal with, having to educate people how to do a proper certificate, and have those people to get their signed certificate on their own, because that's just they probably cut off 75% of all the developers right there. Okay, so here's the question. So what is going to stop me, okay, the malicious hacker, from writing my own Wells Fargo online banking app, okay, so that my app is collecting the password, the username, and whatnot from actual Wells Fargo Bank users, but my backend is actually talking to the Wells Fargo Bank. So to the end user, it seems like I'm the legitimate website or the legitimate app to interact with the Wells Fargo Bank, but I'm actually collecting all their secrets as well. Okay, I'm collecting all the username, all the passwords, and I'm just choosing the right time to make use of that stuff, transfer money into my Swiss account, and then just cross over to the other side of the wall. Whether to the north or to the south doesn't really matter. Just have to go over, get over to the other side of the wall, right? Okay, so what is stopping me from doing it?
Nothing.
Nothing, except that app is being pushed out through Google Play. Okay, because most Android devices will not let you install anything from an email attachment or by downloading a file. Okay, because by default, you can only install something from Google Play. So if it is installed from Google Play, there's a trail. Does that make sense? So if a malicious app is published through Google Play, then it leaves a trail. So whoever goes, so when the end users want to complain about this app, and their account got, money is stolen from their account and stuff like that, Wells Fargo, not Wells Fargo, but Google can now do an investigation. Which app is doing it? Okay, it's this app over here. How did you get that app? They can find out, which Google Play account was pushing this app. Okay, and then from there, what do you think Google can do to try to find me? You have to sign up for the account, right? Whenever you sign up, you have to pay $25. How do you pay those $25? Do you think, I'm going to enclose $25 in an envelope and send it to Google? Do you think that's going to work? You cannot send in cash, right? So you need some form of online payment. And that form of online payment also leaves a trail to you. or to me in this case, to the hacker, right? So there are several things that people can track down. Okay, who is the responsible party for this fake Wells Fargo banking application? So as a result, it does help to stop most people from doing something like that. So the key is not the certificate itself; it is the publication mechanism. Okay, so if you have an Android app, okay, I can probably use the emulator app too. And you go to the settings. So once you go to the settings, you go to security. And under security, it's actually about middle part of the security part. There is a tab called unknown sources. And it's by default turned off, which basically means you do not allow installations of apps from unknown sources. And anything other than Google Play is classified as unknown source. Okay. It's just a very gentle way to say it is not trusted. Unknown source means not trusted. Okay? So if you want to summarize all of this discussion so far, is that a certificate in an Android app doesn't do a single thing about actually authenticating who the developer really was. Okay? But it does one thing that's useful. It establishes the developer. Now, it can be fake, can be whatnot, can be a fake developer, but anything, all the apps coming from the same developer can access the same resources on the Android device. So, okay, so let's just say that I'm the fake Wells Fargo developer, right? So if I publish a online banking app, an investment app, and also a fortune-telling app, using the same certificate. These three apps will now have the same user ID in Android, which is basically the same user ID in Linux, which is the underlying operating system. So they can now share resources. They can see each other's folders, they can see each other's files, and stuff like that. So the apps coming from the same developer can automatically share resources. And then the other thing we can also do, is to update these particular apps. Okay, Android will not let you update an app unless the new APK has exactly the same certificate as the one that it is supposed to replace. So the certificate does do something, except it is not really what you think a certificate would do. Are we okay with that? Okay. So it's a very easy process, but as a result of the easy process, it doesn't really do a whole lot about authenticating the developer identity, but it does do something with identifying the unique developer so that you can do some management as far as applications are concerned. Okay, so we're going to go back and talk about signing. Okay, signing is basically here with basic authentication. So what we do with signing is you generate a signature of the content that you are going to distribute. A signature is nothing more than a hash value, and the hashing mechanism can be very simple, can be complicated, it can be public. Okay, so there's no encryption going on as far as the generation of the signature is concerned. Once the signature is generated, then it is going to be encrypted. But the encryption is going to be using the sender's private key. So whoever is originating the content, the sender, is going to use the sender's own private key to encode or encrypt the signature. So you have the encrypted signature being sent along with the content. So whoever is receiving the content will now look at the content itself, use the same algorithm to come up with the computed signature, use the sender's public key to decode the encrypted signature that came along with the content, and then try to match the two. Because on one hand, you have a computed signature from the perspective of the recipient. You have the received and decrypted signature from the recipient's perspective. If those two do not match, then the authenticity of the sender cannot be established. But if they do match, then you know that whoever is sending the content is the party that has the private key of the public key, corresponding public key in the certificate. But that is as far as you can go. You just know that whoever is originating the message or the content has the public key has the private key corresponding to the public key that is included in the certificate, but no more than that. So if the private key is lost, if somebody stole it, okay, then you can get all kinds of fake content and not know that they're not from the original content provider. Is that okay? So that's basically how a certificate itself is signed. It is signed by another certificate. It's signed by the private key of a root certificate authority. And then the signature, the signed signature, is included in the certificate itself. But it is also including the public key of the root certificate. So now you can double check it.
Thank you.
Yep, sure.
I think it actually makes sense.
Yep.
Fine.
But it is all based on key pair encryption, which is kind of really cool. Which also means, the day when key pair encryption is broken, a lot of things will be broken.
It's time to go to lattice encryption.
Yep. Lattice encryption. What is that?
That's the only one that is quantum computing effective for. It's the only encryption algorithm left. Yes, I think so far.
When we have quantum computers.
If you look up quantum computer decryption, it's like lattice algorithm.
But I think it's still vulnerable to P versus NP. If they
everything's vulnerable.
Oh, yeah,
I mean,
yeah.
that's the. But quantum computing changes the game considerably.
But some of the vulnerabilities are intended and not accidental, or it's a bug, or somebody just
feature.
It's a feature. Okay, so
it's
it's
a CIA backdoor.
It's a backdoor. So RSA encryption is known to be have a backdoor that is based on inspired by not Homeland Security. What is it? NSA. That's the National Security.
Yeah, NSA.
So if you look up these two, exclusive, NSA infiltrated RSA security more deeply than previously thought. Okay, so this is old news. Okay, 2014, 3 years ago. Okay, so I'm not going to read this article. You can all you need is just to find RSA, NSA, and they will give you all the articles they will ever need to read in order to find out what happened. Okay, does someone want to summarize this whole thing? What is this whole deal about?
They have a mathematical master key to all the private keys or something.
So RSA is a private company. Okay, it's not supposed to be affiliated with any government branches. Okay, and they do encryption research and whatnot, and they also push certain algorithms or best practices to the community at large, so that people know, okay, this is how we do encryption and stuff like that. Okay, so the NSA allegedly tell the RSA and say, okay, we want you guys to have to use this particular way to do key pair generation. Okay, and if you choose a particular way to do key pair generation, that particular method can be by design prone to be broken. Okay, prone to be you can use an effective way to break the key.
If you have one, you can go the other way. If you have the other, you can go the other way.
Or there are just special properties about the keys so that it's easier to broken. Okay, and that's basically what happened. The NSA, which is a branch of the government, allegedly told RSA, which is the encryption company, or the company that originates most of the encryption algorithms and mechanisms, and also key cards, okay, and stuff like that, to use a particular method of doing key pair generation that has a known vulnerability, so that if the NSA ever needs to, it can go to any server and break any type of encryption, so they can actually read the content of encrypted content. So that's the allegation. Okay, so whether it is fake news or actual news, that's entirely up to you guys to read and decide on your own.
There is no such thing as fake news in 2014.
Yeah.
It didn't exist before, huh?
Back when the world was real.
The reality bubble did not exist.
Now the world is making the internet's real.
Okay, so I'm just reading the first paragraph. Okay, security industry pioneer (RSA), which is actually the initials of the three people who started the company. Okay, adopted not just one but two encryption tools developed by the U.S. National Security Agency, greatly increasing the spy agency's ability to eavesdrop on some internet communications, according to a team of academic researchers. Okay, so that's basically the allegation.
For $10 million.
For $10 million.
Oh,
Yeah,
so now we know their
that's like
price.
chump change, right?
We spend more than that tracking Snowden.
Yep. So it's basically chump change to make a now discredited cryptography system the default in software used by a wide range of internet and computer security programs. So there you go. This reminds me of a very early movie on computer security, Sneakers. Has anyone watched that movie, Sneakers?
I saw the computer that wore tennis shoes.
Yeah, there's that. Okay, so this is highly recommended if you're if you want to get into computer security and how it intertwine with politics and stuff like that. This is actually a pretty good movie. I don't know why it's only rated 7.1 out of 10. But from the standpoint of computer security, it's actually pretty good. And if you read the storyline, it had to do with. Go ahead and watch the movie. Okay, I'm not going to spoil the story for you.
Homework assignment.
Homework assignment. Write an app, inspired by Sneakers.
Actually, 7.1 out of 10 is actually pretty good for an average rating.
Is it? So it's a pretty good movie. It is realistic enough that people can actually believe it. Okay, but it also has that element of intertwining technology, and computer security with politics, spy intelligence organizations and whatnot. And the surprising thing is, it actually is closer to reality than we think it is.
What was the one with Angelina Jolie? It was Hackers. I don't know. There was one movie in that same era that was just so
Horrid.
unrealistic. I couldn't even finish it.
Yeah, I watched this one and I thought it was actually pretty good. I mean, it was fairly realistic.
Oh, can I?
So watch it, if you have a chance to watch this movie.
For $3 on Amazon Video.
Hmm?
I said, oh, for $3 on Amazon Video.
But that's only SD. Which is
I know,
already
Is it available on Prime?
Hmm?
Just
No.
kidding.
Nope.
For free.
Nope. Otherwise, they would say that. 'Cause then they can sell you Prime.
Okay, so the storyline is Martin Bishop is the head of a group of experts who specialize in testing security systems. When he is blackmailed by government agencies into stealing a top secret black box, the team found themselves embroiled in a game of danger and intrigue. So the key is, whether this black box is supposed to break encryption from international communication or whether to break encryption from internal domestic communication. So that was the whole crux of the movie is, are we doing this to decipher, encryption or, secret messages going outside and into the United States, or are we trying to break encryption within the United States? Okay, so I'm gonna leave it up to you guys to watch the movie and find out what the answer is.
It's on Netflix.
Huh? Oh, it is? I was just looking at Netflix.
Stream or DVD?
Actually, that says DVD.com. I clicked Netflix, but it's
Yeah, it's really
Yeah,
old and not a whole lot of people
yeah,
are gonna
no,
watch
it's
it, so
not
you
on,
won't stream it. Yeah, they won't stream something like that. Okay, so here we go. So key pair encryption stuff. Are there any questions about encryption so far? With key pair and whatnot. No questions? Okay. So I'm not going to go too far with this one. This is all basically done already as far as key pair is concerned and how Android makes use of key pairs and certificates. So now the big topic is how do you sign in a user, okay? Because in many cases, your application probably has a need to sign in a user, okay? If you need access to anything that has a back end of database, you probably need to sign in and authenticate. Is the user really who the user claims to be, okay? So I did some research on Google sign-in first because that was requested on Monday, okay, and it was on the list of items that I need to do some research on. So I did take a look at that. So I looked into Google sign-in in general, Google sign-in integration in Android, and also the underlying OAuth 2.0, protocol. And then through looking at all these links, I also found this. Okay, so I'm going to open this tab here, which is Firebase DB. Authentication. If you took cisp362 in the previous semester, you already know what the Firebase DB is because we talked about that in that class as well. So what we did not know or what we did not discuss is Firebase DB is actually a lot bigger than how we use it in App Inventor. So instead of doing the pitch myself, I'm going to play Google's own spiel on this subject matter. I just have to make sure that my audio channels are connected correctly so that my output device is enabled and turned on. Okay, we want the volume to kind of go up, and we'll go ahead and play this.
Firebase makes authentication easy for end users and developers. Most applications need to know the identity of the user so they can provide a customized experience and keep their data secure. Firebase supports lots of different ways for your users to authenticate. If your users want to authenticate with their email address, you can build that for them. Firebase Auth has built-in functionality for third-party providers such as Facebook, Twitter, GitHub, and Google. It can also integrate with your existing account system if you have one. You're given the choice about how to present login to the user. You can build your own interface, or you can take advantage of our open source UI, which is fully customizable and incorporates years of Google's experience in building simple sign-in UX. No matter which one you use, once a user authenticates, three things happen. Information about the user is returned to the device via callbacks. This allows you to personalize your app's user experience for that specific user. The user information contains a unique ID which is guaranteed to be distinct across all providers, never changing for a specific authenticated user. This unique ID is used to identify your user and what parts of your backend system they're authorized to access. Firebase will also manage your user's session so that users will remain logged in after the browser or application restarts. And of course, it works on Android, iOS, and the web. That's Firebase Auth, allowing you to focus on your users and not the sign-in infrastructure to support them.
Okay, so if you don't pause it, it will automatically play the next spiel and the next spiel and so on. I mean, there are a lot of interesting stuff. Now, understand that this is promotional material. Okay, so it is only letting you know of what is really attractive about this. But when you get to use it, you might find that some of these things are difficult to use or something along that line. But the interesting part is you can utilize the quote-unquote third-party providers for authentication. In other words, you don't have to build your own user database. All you have to do in your own database is to use the unique ID that is guaranteed to be unique across all the platforms to identify end users.
So that means it's going to be the same whether you're in Facebook, if you're
no, it
on
means
iOS?
it means if you use okay, let's say I'm oriented in Google Gmail and oriented also at using Facebook. It basically means it's guaranteed that those two accounts will be distinct. They are not going to be the same.
Not the same.
They're not going to be the same. So if I use oriented at Facebook to sign in, I'm going to go into a different account compared to using oriented at Gmail to sign in.
No, I thought it was saying that no matter what you use,
You can
it's
share
going to
your
give you the
data.
same user ID and
Yeah, that was the magic, is that
Yeah.
once you were going to be you, that you could be on iOS and Android and access the same data. You would be
Yeah,
the same distinct
that's
user.
what it is. As long as you're signing in with the same, like if I
Same
sign in with
provider.
Google, like if I sign in with my Google account, it's gonna pull it no matter what device.
Right.
But if I try and sign in using my Facebook account instead of my Google one, that's a different account. So it's gonna think it's a new user.
That's how
With-
I
with-
interpret the.
With rare exceptions, some apps will allow you to link multiple ones. And so, like, let's say this app, whatever app you're doing with Firebase, allows you to link multiple services. Then you could sign in with either Facebook or Google if you already linked it.
Yeah, that's how I interpret it too. Is if you sign in using Google Gmail, it is considered a different identity compared to when you sign in using Facebook or GitHub in this case.
And at the same time, when you sign in with Gmail or your Gmail address, it's the same whether you log in on iOS, Android.
Yeah.
That is
or-
correct.
Exactly.
Yeah.
Right. So you get connected to the same point.
Right. Now, Firebase DB is also interesting in the way that it can push updates of the database. Because with a normal database, okay, so let's say you're using MySQL or Oracle or something like that as a backend, a database is sitting there as a server. Basically, it's saying, okay, if you have a question, I can answer it, right? So let's say I'm a database and multiple applications or multiple installations of the same app needs to access the same tables, okay? So when one app updates me, okay, I'm the database, and I go like, yep, I can update the database, I can update this table, I can make all the changes, no problem. But I'm not gonna let all of the other installed devices know about the update. All of the other devices would have to poll and say, hey, database server, what happened to this particular table? Are there new rows compared to the last time I checked? And they all have to run that query to find out whether there are additional updates or not. Firebase DB, according to what the spiels has to say, and also what we learned in cisp362, it has a notification mechanism where you can basically be watching a particular table. So when the table changes, it automatically sends a notification to all of the other installed running applications, so they can all be notified and go like, oh, this table just got changed. And according to the spiel, it is all within hundreds of milliseconds. Now, this is really interesting because it means if you want to make your own application to keep end users connected, this is an automated mechanism because you just have to implement the callbacks to what happens when a particular thing is updated, and then your app will just get a notification, and then you just have to say, okay, I know something has updated. Let me do what is necessary to bring that stuff on the screen, or do whatever you need to do about that particular update. So it's not just a database backend that is sitting unless somebody is asking it to do some changes. It actually propagates the changes, or it notifies other installations about the changes. The other interesting part about Firebase DB is it also has an offline mode. Okay, so if you're using Oracle or MySQL or PostgreSQL, a traditional kind of database, if you're moving out, and you have no internet access, your 4G is dropped out, you have no Wi-Fi connection whatsoever, you just lost complete functionality of your entire app because there's no way to contact the backend. Firebase apparently has some kind of offline mode where you can make local changes to Firebase. So when you get back into a range where you have internet connection, then it will reconcile the changes that you have made locally to the remote database. Now, whether that can be done in all cases, I'm pretty sure it cannot. Okay, it doesn't make sense, right? So let's say you're talking about a purchasing type of transaction. You don't want your app to be making a purchase offline when you're camping, and then the moment you drive back into the city, you just found out that you have just made a lot of purchases. Because, well, one, it may not even happen because it may attempt to update the database. What if it's sold out? What if there's no inventory left? Okay, so I'm pretty sure for certain things you cannot have offline update, but for certain other things you can probably do it with an offline update. So Firebase apparently has the ability to do that. So let me see if I can continue the playing of this.
Firebase makes sending messages to your users easy with Firebase Cloud Messaging. It's a free service that allows you to send messages to your users' apps across a variety of platforms. Messages can be addressed to single devices, groups of devices, or even topics. Building a notifications or messaging system with Firebase Cloud Messaging is easy. First, you register your user's app instance with the Firebase Cloud Messaging servers. Then, on your server, you write code that allows you to address these devices by ID, group, or topic, and which tells the Firebase Cloud Messaging server to send the messages for you. It's powerful, it's scalable, delivering hundreds of billions of messages per day, with 95% of messages being delivered within 250 milliseconds to connected devices across many different platforms. It's that easy, it's that powerful. Firebase Cloud Messaging.
And we'll watch this one too.
When you're building an app that needs to store and share data from a server, there are a lot of things that you'll need to keep in mind. Setting up and maintaining a database can be a hassle. And if you want your data synchronized in real time or need offline support, well, now you're talking some serious time commitment. But with the Firebase real-time database, you can get that time back. The Firebase real-time database lets you store and sync data between your users in real time. This makes it easy for your users to access their data from any device, web or mobile, and it helps your users collaborate with one another. Whenever you update data in the real-time database, it stores the data in the cloud and simultaneously notifies all interested devices in milliseconds. The real-time database is also optimized for offline use. Whenever a user loses their connection, the database SDK uses a local cache on the device to serve and store changes. This means that when the user comes back online, their local data is automatically synchronized. And how do you keep your data secure? You can use database security rules to specify who has access to what pieces of data and how your database should be structured. The security rules are securely stored with the real-time database on our servers. So if you want to make sure your users can only access their own data or ensure that their message is no more than 141 characters, you can do that in just a few lines of code. Getting started only takes a few minutes. The Firebase real-time database is hosted for you in the cloud, so there's no server maintenance or operations. And there are SDKs for Android, iOS, and JavaScript. To get started with the real-time database, check out our Quick Start, which will get you up and running in minutes. We can't wait to see what you'll build with Firebase.
Okay, they kind of lied. It's not exactly in minutes.
Well, it's a whole bunch of minutes.
Whole bunch.
Yes,
Yeah.
a whole bunch of minutes, and they actually have these case studies. So if you scroll down to case studies, you will find that the quickest case study to get it integrated is about half a day, and then most of the other ones are like from 1 to 2 days. But it's still not too bad, okay? Considering
Probably
you
get
don't.
the bare bone essentials done in minutes, and then it probably to get full integration probably takes a couple.
Right, and also specify all the security rules, what
Yeah.
can be, offline updated, what cannot be offline updated. So I'm pretty sure there's a lot of intricate details that you have to really figure out in order to make your app make use of Firebase DB. But the whole point is you don't have to maintain your database anymore. So instead of having your own server to maintain your own database, back it up, make sure it is up and running, and when your user base, is increased, that your service can scale up. This is all done offline. I mean, this is all done, using the Google backend, and it is scalable. That's basically the biggest selling feature that they're trying to tout. Is it's all centralized. You don't have to do a single thing. Just use it as a service. And they charge you accordingly, okay?
Yeah.
So when your app, grows to have millions of users, then you start to pay more for the service. But if you only have like 30 people using your app, it's probably not too much money that you have to pay.
I think I saw it had like a free tier.
Yeah, it has a free tier. The Google API is one of the things that you might want to look into. So Google API, actually got the link already. and Google Cloud Platform. So Google API is a part of Google Cloud Platform, which I think is Google's version of AWS. So you can run your own virtual server if you want, but they also make it so that you can run your own quote unquote app without a serverless kind of app. So this is Google Cloud Platform, and now that Amazon, AWS had it, snafu, like last week, I'm pretty sure Google Cloud Platform is getting a few more customers as a result.
Oh, yeah.
And then we are just waiting for Google Cloud Platform to make its own mistake to push customers back to AWS. So that would be kind of interesting.
And then they go to Azure.
Huh?
No. I like that Amazon will give you like a free year of their service.
Mm-hmm. And they also have a free tier too.
Yeah,
But it only lasts a year, right?
Yeah, the free
And then
trial is
all
like
of a sudden, if you
year.
left any instances running, you get billed for it. I know. So if you ever do it, shut it down.
Make sure you you set a reminder 2 weeks from your expiration dates,
Yeah.
so you remember. Oh, I have those running. I
There's
need
so
to shut
many
them down.
things you could set up. I mean, it's hard to find every last one of them.
Yep.
I think I left an IP address that was remote forwarded or something, but the bill on that was huge.
But this is you don't even have to run your own virtual server. That's the whole point of Firebase, is you just use the product already in place, and you don't have to run your own backend anymore. And I think that there's a lot of attractive features to that whole thing of not having to maintain your own database or your own server. Now you lose control of that too. Okay, so you're losing control, but you're gaining in terms of simplicity. So you don't have to run your own server. You don't have to make sure that your server is up to date with its own versions, and all the software packages are updated as well. You're not updating to a point where it is no longer backward compatible and stuff like that. That happens a lot. Okay, most people do not understand that when you upgrade or when you maintain your own server, the first time you set it up, it's like, oh, this is cool, this is a lot of fun, and then down the line, it will become like, oh, this is a lot of chore. Okay. Especially if you use PHP.
That's why I have Midface. They handle all of the operating system stuff. I just worry about my website files.
Now with Firebase, you still have an issue because whenever Android itself updates, you still have to get the Android updates and find out whether they are including new features, whether they're deprecating old features and whatnot. But PHP has a really bad habit of not deprecating old features, but completely making it not functional. Like completely breaking, a backward compatibility. And this is all within PHP 5. So we're talking about PHP 5.1 blah blah blah, versus 5.3 something. Okay, some features are completely gone. It's not just deprecated, and then you have to make a lot of changes to php.ini, the configuration file, just to keep things going.
They certainly like to keep things interesting.
And I'm also interested in knowing what happened to PHP 6.
I've used
It was a Frater 7.
I've used like forward compatibility modules and stuff to fix PHP problems.
Yep. And it's unique to PHP because if you write, okay, I'm not sure how many people here write scripts in Perl, okay, but Perl has extremely good backward compatibility. Now they do deprecate things once in a while. So when you run the script, on the command line, it will show messages and go like, oh, this is now deprecated. You're not you should use this new feature instead and stuff like that. But they never take it out completely. So your new script, your old scripts will always be runnable using a newer version of Perl, even though it will say, okay, this is not recommended anymore. This is the new way of doing things and whatnot. PHP just completely breaks stuff, okay? And this is within version 5. It's not going from version 5 to 6. And I don't know what happened to version 6. That was my earlier question, because I have not updated the Power Server for about a year and a half or so. In terms of the software installed. Okay, I look at Apache. It went from some 2.3 to 2.4, some minor changes. The kernel went from 3 point something to maybe 4 point something.
Yeah.
But that usually has no implication as far as the applications are concerned. PHP went from 5 to 7. And that's why I asked, what happened to 6? Within a year, it went from 5 to 7. Did you guys know what happened to 6? I mean, did it have a very short lifespan?
I think it was on the Samsung
I
S7.
read about it, but I forgot what.
It was a 6 was afraid of 7, so it ran away.
It's just like Windows, Vista.
Oh God.
So, there you go.
Yeah.
So I'm not the only
Something
one.
to do with their versioning, because 7 was I don't remember why.
Okay, here's a slide deck post-mortem. They made some bad decisions about Unicode and everybody got burnt out. They skipped 6 because 7 contains none of the Unicode changes and didn't want to confuse people. So they made some really bad moves in version 6, and then they quickly realized the mistake, and then they reverted back to the old way of doing things, but they can't call it 5 anymore because it's not 5, so they have to name it 7, I guess.
So we have the same problem if our apps want to share data too. It becomes a versioning issue.
Firebase.
No, just our apps. If we want to collaborate in any form, and then we update our apps, we have versioning issues to stay compatible with backward versions.
With the STK versions, right? You're talking about the level
Just use
of
it,
Android.
just our own data that we store in our own database. If we want to upgrade our own apps, we have
Correct.
our own versioning problems that we have to keep carrying with us.
Yep.
And carrying with us.
Yes, and you remember when we talk about SQLite, that discussion of SQLite, when you use SQLite, you have a
Table upgrade.
callback of updates. So when the SDK or the library detects that your current version is not the same as, okay, the app version does not match whatever version is stored in the database, it will automatically call a callback function with the old version, which is what is reported by the database, and the new version, which is what is reported by the app itself. So if those two are different, you have to basically specify your own logic and your own SQL queries to bring the database from whatever reported old version was to the current version.
Which really means we should probably upgrade from version 1 to 2, and then
Yes.
go 2 to 3, and then
Yep.
3 to 4.
Yep, exactly.
Instead of trying to go from 1 to 4.
Exactly, unless you have some really tricky stuff that happened between certain versions and you cannot go sequentially.
In this case, they went from 5 to 7.
Yes.
Skip 6.
Yeah, skip 6 altogether. Yep.
Could you specify logic? So let's say evens are development builds of the database, and the
That's
other.
your kernel tradition, right? The kernel tradition is even numbers are the ones that are released, and then odd numbers are the ones that are in testing.
Yeah.
Yeah.
Could you specify logic in an Android app to do that, or?
That's entirely up to you because the versions are under your control.
It's your problem.
Yep.
Or opportunity.
Yep. Or opportunity, yes. Or challenge. Okay, so
Challenge
we got a
accepted.
few more things to go over. This is Google Sign-In, which I think is good too. If you are not using Firebase, this link it will tell you how to use Google Sign-In, but then it is locked into just one single provider. You cannot use Facebook, you cannot use GitHub. It is just for Google Sign-In. Okay.
And likewise, we could implement single sign-on for Facebook if we use their API.
Yes.
Yeah.
Yeah.
We
I'm
could
pretty
do
sure.
all the hard work if we wanted to.
Right. So Firebase, what Firebase did is to unify, the 4, providers up to this point, and you have to go through only one single API to deal with all 4, basically. And I think all of these things will change too, in the future, where you will probably end up with like 1 or 2 only, providers. So these things will continue to merge. And individual developers, developing apps will no longer try to handle their own accounts. One example is Pokemon Go. Okay, so when I did Pokemon Go before Pokemon Go stopped running on rooted devices, because mine is, they provided 2 ways to set up your account. So one way is to use the Pokemon Go account, and the other one is to use Google Sign-In. So Pokemon Go, has Google Sign-In integrated into it to identify, who you are and stuff like that.
You heard what they did with that, right?
With what? Pokemon Go?
Yeah.
No.
Oh, they
Didn't they reset everyone at one point?
no.
The day that they said, all rooted users are cheaters, I stopped playing. Because I didn't cheat, I was using Pokemon Go as an excuse to go out, walk around, and do some exercise. Okay, and my device was rooted because I got some other reasons to root it. I want to be able to, install, applications that can, navigate to all the different folders and stuff like that. And and if they claim that all rooted users are cheaters, I'm just not going to use that app.
Yeah.
And you're looking up a Pokemon Go.
Yeah, it said this. So Pokemon Go is a huge security risk based on the authentication aspects. In order to play the game, the user has to have an account. But when they use the Google authentication method, they opened up the permissions.
But the permissions will still be limited to
Oh yeah.
the app itself, right?
Yeah.
Yeah, there was some big scare about that, but from what I was reading, it wasn't founded.
Okay.
I'm not
So
sure if that's the same thing that you're.
Yeah, I think you gave them access to like your contact list or something, so you could
Right.
determine who is playing around you. But
Yeah.
what they do with this data is
Right.
where they got themselves in trouble.
Yeah, but you can deny some of those, permissions. Like,
Like
it's
deny
just
everything
like,
always.
right. It's just like what we talked about when we talk about cameras. Remember, you in newer versions of Android, you can no longer just permit it, in the installation process. When the program runs, it will ask you for permission, and that's what happens to Pokemon Go. If you do not let it use the camera, in order to use augmented reality, it will every single time you start it up, it will ask you again. Okay, can I use the camera? No. And the next time you start it will ask you again, can I use the camera? No. I think there's a little checkbox that says, do not ask me this question anymore. Okay, but that's what it is. This is also an interesting article that I found about bad certificate management in Google Play Store, which is basically saying about the self-signing certificate. And you can read about it. And Blue Box recently reviewed a fake ID vulnerability, which exploits an app's certificate verification process within the Android OS. If they haven't already, soon attackers and malware authors will turn their attention to exploiting vulnerabilities surrounding Android app certificates. So it's not like they're not without their own problems. There are all sorts of problems too. And the key is, if you want to install something, you want to kind of install it through the Play Store and not from a website. So downloading a file from a website and installing it is probably not a very good idea, because it compounds on the existing problems.
And you got the rootkit, or you got the rooting software from Google Play?
The rooting software? No,
Yeah,
it's
you
a
rooted your device, so you installed it from a website.
You have to get a zip file from xda-developer.org. So you have, it has to be device specific as well. And the way you install the rootkit is you have a zip file that you have to quote unquote install through your bootloader. Not a bootloader, excuse me, your recovery.
Yeah.
So the first thing is you have to change your recovery to one of the recoveries that can install from a zip file. So you unlock the phone first, if your phone is unlockable, and then you install a custom recovery like Twerp or Clockwork. And then once you have a custom recovery, then you can install whatever image you want to install. You can use not CyanogenMod, Lineage OS, or some of the other alternative images. And once you have the other images, then you can install the root zip file, which basically install SU, the executable and a few other utilities, so that you can gain root access, on your phone. It's a whole chain of things. And some devices are fail-safe. In other words, they always guarantee that a particular startup image cannot be changed. So you can host your entire thing, and you will at least be able to get to a certain point of your device where you can reinstall everything. Other devices do not give you this safety net. In other words, in those other devices, you can literally break your device and it
Now
becomes
you have a
permanently
couple
not
hundred.
usable anymore.
Yeah, you now have a couple $100 paperweights.
Yep. And I think the Nexus 5 is one of the not safe one. You know, it is a, yeah, in automotive terminology, it is an interference engine. You break your timing belt, all your valves will, all the valve stems will be broken. But there are some devices that are safe, you know, where you cannot get to that point. All right. So any questions? So I'm moving down the list, you know, a little bit, and I think what I'll do over the weekend is actually, you know, going to use Firebase and give you guys an example of, you know, how to utilize, you know, Firebase as a back end of a program that needs some kind of data storage per user.
I like that idea.
Yep.
So if I wanted certain users to have editability and then other users to have readability,
Right.
I think Firebase would be.
I think you can set it up, you know, because they
That's what
said, okay, I remember distinctly, you know,
It said, yeah.
the guy said, you know, they store security rules securely on their servers. So I'm pretty sure you can set it up, you know,
It's
you
like
just,
if you had an admin version of the app, like let's say it was like a support app, you could have your admin one where it can read and write to things, but
So I could have the app have a code that you need to know in order to access the.
you first have to establish the identity of the user, whoever is trying to access the database, and then based on the identity of the user, then it will look up the rules associated with that particular database and say, okay, this particular user is set up only to be able to read these tables, write to these tables, and only, you know, and not allowed any access to all those other tables, which is basically the same thing of what you have to do with MySQL, Oracle, or any other type of database, is you can grant different types of permissions or access based on, you know, which user you're dealing with.
Okay.
So I think it is the same concept, except, you know, you're not using SQL queries to do it. You're basically going through some kind of, you know, proprietary Firebase interface to do it.
But then I guess the problem is that the app's distributed and then I have a certain group of users I want to be able to have edit. They don't have accounts when I'm setting up the app. So there has to be some way after the app is installed to go back and add users to the database.
I see what you mean. Okay, so you have an app where you have a set of users who will request, basically they need to request to have access at a particular level. So I'm guessing, you know, the logical solution to that is to have group management. In other words, you're not granting permission on a per user basis, but you set up, you know, what we would call logically a group, and say, okay, anyone within this group is automatically granted, you know, grant these particular access permissions. So in that case, you know, what you need to do is to have the new user who signed in to basically request, you know, access to something, or have some kind of automated way to, you know, verify that this person or this particular end user is, you know, supposed to have, you know, a specific kind of access, and then you just say, okay, add this user to this group, and then that user will now automatically inherit the permissions of the group. So I would imagine, you know, that's how Firebase is going to manage the access limitation or the access control part of the database. It seems to make sense that way.
Yeah, okay.
Yep. So, you know, I'm going to spend the weekend to, you know, kind of play with Firebase, because I think it's really kind of interesting. It addresses one of the main issues of modern apps, because most apps are user oriented and you need some kind of sign in to get something that is specific to a user. Because, you know, standalone apps are not really common anymore. You know, I have a ballistic, you know, calculator app. And even that one, you know, has a sign in, because it stores, you know, all the data, all the things, you know, in the cloud. So, you know, it's every app that I know of, you know, are basically cloud based. My calculator is yet to be cloud based, but I wish it were. Because then it can keep the configuration in the cloud. So when I upgrade from one phone to another phone, or if somebody roll over my phone, I can get a new phone, and I get everything back, including all the settings.
Previous calculations.
Previous calculations, exactly, the whole stack, because I use RPN.
So you run over your phone and you get an HP 11C back?
Okay, so for those of you who missed those old calculators, this is the app that you might want to look into. It's called RealCalc Scientific Calculator, and you can see that it has the kind of look of the older calculators, and it has RPN too. So this is a screen of the RPN screen. So you have a back button here, and there's an enter button to push something on the stack. So this is actually using RPN, reversed Polish notation. And my calculator is set up exactly to do that, using RPN. But I didn't actually grow up with RPN calculators. I just grew to like them.
Are you using the built-in calculator in the phone, or are you using a special app?
Oh, this is a special app.
No, the one on your phone.
This is what I use
that's
on
the
my
one you're
phone.
using. Okay.
Yeah, this is the calculator app that I use on my
Okay.
phone. But the configuration is not saved, based on my account. So every time I move to a new device, I have to reconfigure the calculator the way I like it. All right. So I'll see you guys next week, and we will basically be able to add database backend capability and user authentication capability to what we already have. So that will kind of give you an idea of what kind of app you can write for the next 7 or 8 weeks, because now we have all of these individual pieces. It is up to you to decide, okay, how do I want to integrate all of these pieces to do something that I find is useful.
I think I'm going to write a standalone app.
That's kind of where I'm at.
And then later on, everybody in the same classroom can share pictures. But that's later on.
Later on. But you have to build that in too, because otherwise later on becomes very hard.
Yeah.